In this unit, we are going to introduce the idea and concept of networks that is going to be central for the future discussion on the complexity of music. And so right now, I think it's the first time in this course that we actually start dealing with concepts and ideas that come from complexity theory. Many of you are probably familiar with the idea of a complex system, of a complexity, but I just want to remind you very simply what complex means in terms of the definition of the word and what complexity entails given the meaning of the word. So complex in English is an adjective and means something that is composed of many interconnected parts. And this is very essential to the idea of music complexity, because for us, music is a complex system. It's made of interconnected parts that have a complex way of interacting in some sort of generalized way. So out of this definition of a complex system, the science of complexity is a scientific theory that starts from this idea of a system made of interconnected parts that are usually simple, and they behave in a very simple way when looked at individually. But when they are combined, they form a system that has properties that are different from the one of the individual entities and that have properties that emerge from this kind of interaction. And so one of the central ideas of my approach to music as a complex system is that music itself is an emergent property of a complex system, being that either the systems of pitches that we have introduced, or at a higher level, as we will see in future units, the interaction between individual performers, the performers and the audience and themselves, society, and at larger scale, human culture. Networks are important in this framework because behind a complex system, there is a network that describes the elements and the interactions that form that system itself. And so one of the central things that I'll be introducing in the next couple of units is how we can represent musical spaces as networks. Okay, but what is a network? A network is a representation of interaction between agents of points or data. And this is a typical example here in this slide of a network as we understand it in a very intuitive way. This is a transportation network. It shows airports on the map of the US and connection between airports. So what this representation tells us is, for instance, that there are airports that are more important than others because they have more connections with other airports. And you see this, there are at least 5 or 6 important points that are more red than the rest. And then the network of interaction, that is how one airport is connected through flights to another airport. And this gives us not only a way of visualizing the data, but most importantly, a way of making sense of this data given the characteristics of this network itself. Networks are everywhere. There are, and many of us are many of you are probably very familiar with many of them. We have technological networks like the internet, for instance, or communication systems, or electric grid, or water mains, and so on. And we have biological and ecological networks, neural system, disease epidemics. We all went through the COVID years, so we are very familiar, at least with some of these concepts that were we were fed of this through our experience with the COVID pandemic. We have economic networks, we have social networks. All of you and us, we are all part of something, Facebook, Instagram, TikTok, you name it. These are, again, networks where complex interactions can be represented using graphs. And then finally, we have cultural networks like language families, semantic networks like networks of words, and so on. And again, this is something that we are getting very familiar with through the advancement of generative AI and all these large language models that in a way or another exploit the structure of these networks. Now, a network as a graph looks like this. You have nodes, these colored points that are the individual data or agents, and then you have connections, the gray lines, these are called the links. This is, for instance, an example of a network of a company where there are departments, there are consultants, there are experts, and how all these agents kind of interact with each other. Now, in this network representation, we are interested in mainly two specific objects or measures. One is the degree, and the other one is the community structure. And this will be central in the discussion of the networks in musical spaces. So what a degree is the number of neighbors that a single node has. So in this example here, for instance, in the top, we have a few nodes connected by links. And if we look at the different number of connections, the node A has only one connection, and so has a degree 1, while the node B has 4 connections, and so has a degree 4. Networks, actually, this is another kind of important characteristic of a network or a link, can be either directed or undirected. So the top one here is undirected. That means that the links are equivalent left, right, or right, left. While in a directed network, links have a direction. So that basically in the example in the bottom here, we have that the link from A to B exists. That means that in principle there is an interaction that from A operates on B, but not the vice versa. There is no interaction between B going to A. This is also important because, as you will see in future units, music networks are typically directed networks. Now, the other concept that I mentioned here in this slide is the community structure. Now, community structure is a kind of a complex quantity to evaluate. There are many different algorithms to evaluate the community structure, but in very general terms, it means that in a network, we typically have nodes that are more connected in an environment than others, and so they form some sort of communities or groups that are more well-defined than like the whole of the network itself. To show you this in a practical example, this is a graph of my Facebook network of quite a few years ago, because now Facebook doesn't allow you anymore to download your network, unfortunately. But at that time I did that. I downloaded it. And you see here a network that has very well-defined kind of groups of nodes. And if I look at the nodes individually, I can identify groups, for instance, a group of all my musician friends, or a group of all my physicist friends, or all my Italian friends. And some these groups might have interaction with each other, but they are very well isolated and very well defined. So this is important in the next discussion, in the future discussion of musical networks, because as we will see, we can use this community structure of the network itself to identify very specific quality of the music that emerge very clearly from this kind of representation.